everyone, so it's good to see you all again. I'm Natasha and welcome back. So today we're going to continue our 5th chapter and it's complex numbers and quadratic equations. So in this video we're going to discuss about a question. So we're going to solve a question related to the square root of complex number, and this topic was discussed in the previous video. So as I told you before too, that we'll be like solving a question, and we'll be using 2 different methods. But yeah, I want to say that like those 2 methods are like almost same to each other, but the difference is that in first method there's something else is used, and in the second method we have used the formula. Okay, so that's what the difference I think is. So let's get started. Okay, so I haven't written the question, so let me write the question. It's a really short question, okay? So it's a practice question, so let me directly write it. So what is it? Okay, we're only going to discuss one question, okay? Only a single question. So it's find the square root of 8 minus 6 iota. Okay, so we'll be finding the square root of this complex number by 2 methods. Okay, so the first method, I'm gonna say first method so the first method is really easy. What we have is our complex number is 8 minus 6 iota, right? Okay, so let me write it. So let's say this is z, okay, complex number z. So sorry, yeah. So I'm saying this z is a complex number which is equal to 8 minus 6 iota. So to find the square root of z, we will actually first have a look at its magnitude. Okay. Oh, wait a second. So this magnitude is coming in the complex number topic, but it actually means the modulus. Okay. If if you have really watched the vector, the video in which I was discussing about vectors, right? I'm not sure exactly about it, but I think I have discussed about it. So that this magnitude is for the modulus. So whatever. So what we have here is that we're gonna find the modulus. Okay. So just have a look. What is our complex number? It's a z. Okay, and to find the square root of z, what we're going to do? So let me just clean this thing, and I'm gonna write something else except this one. Okay, because it's this method first. So I'm gonna say let z square is equal to x plus iota y square, which is equal to 8 minus 6 iota. Is this clear? So what is it saying? That we have let this z square is equal to x plus iota y whole square is equal to 8 minus 6 iota. Okay, so what we can see, what we usually have is let me use something else except this. Okay, so we have our x square minus y square, right? Oh, let me change the marker. It's cut it so really light. Okay, and I'm gonna write this again. Okay, so what was I saying that? Oh my gosh, it's really tight. Oh, okay. Oh, I hope you can hear me. Okay, yeah. So what I'm saying is this x square minus y square. Okay, is it looking like a square bracket? Then I'm gonna, make sure to make it a common bracket. Okay, so x squared minus y squared plus 2xy iota is equal to 8 minus 6 iota, right? Okay, so what we have here is that, we can write, to find the, square root of a complex number, what do we do basically is that, first we square both the sides, and then we, on simplifying them, we get something like this, and after then, when we just finally compare the real and imaginary parts, we get something different. So this x squared minus y squared is equal to 8, and this 2xy iota is equal to negative 6 iota, right? So is this clear? Is this clear? So what I'm going to do is I'll be writing the same thing which I just said, comparing real and imaginary parts. Okay, okay, so I'm comparing the real and imaginary part. So what is it? So I'm going to say that this x squared minus y squared is equal to 8 and 2xy is equal to negative 6, right? Yeah. So now let's talk about this modulus thing, okay? But before that, I'm going to write this again. Okay, yeah, so what was I saying that now we're going to discuss about the modulus, okay? So let's consider the modulus. Okay, so we haven't talked about the properties, right? The modulus of a complex number, I think so. But, I think there is no need to discuss their properties. But even if there is any need for that, make sure to discuss that topic with you. Okay, so whatever, so let's consider considering the modulus. So what I'm trying to say is this z squared is equal to this. What is this? What's the difference is that the square is outside the modulus, and then here it's inside it. So what is it saying? That the mod of z, okay, so let's say this mod of z is x squared plus y squared, right? So what is it saying? That x squared plus y squared whole square is equal to okay, I think that's gonna be something more complicated. So I'm gonna write this x. Okay, so it's just I want to say something. This x to the power 4 plus y to the power 4. Okay? Okay? Is this clear? So what is this trying to say? This thing, okay? I think according to me that, okay, it's like x squared plus y squared, and then x squared plus y squared, right? This x squared with x squared, which is gonna be 2x to the power 4. Okay. Well, okay. We're not discussing about it. Okay, so let's just forget about this. So whatever I'm trying to say is now actually, if I'm really gonna continue this, this will keep going on and on and on. So I'm not gonna discuss about it because it will be wasting our time, right? Yeah. So what I'm saying is this mod of, okay, so mod z squared is equal to the square of, okay, so finally I can say it in a real easy way. So what is it saying? That this mod of z squared, okay, I can say mod z squared is equal to the mod of z squared. Okay, what's the difference with this? Okay, so z squared is what is the complex number? Let's say if the complex number is a plus iota b, right? So it's gonna be its square. Okay, so that's what it's trying to say in the mod of this, okay? And this z is saying the mod of z, if it's x squared plus y squared, then this, this will be like, so both are different, okay, both are different. Whatever I'm saying is that it's talking about the complex number z and it's talking about the modulus of this complex number, right? Okay, so no need to get confused, and we'll be not like talking too much about the properties because I'll just discuss them later on, okay? Yeah, so considering the modulus z squared is equal to this, and so what I'm gonna write according to this thing is that I'm gonna say this x squared plus y squared. Okay, x squared plus y squared. Should I take it in under root? Should I? Well, of course I'm going to take it, but let's take it here, okay? So, what's the x squared? 8, right? Y squared? -6, which is going to be positive, as here it is. So, 8 squared plus 6 squared, which is going to be, what is it going to be? Okay, so let's see. 8 squared will give us 64, right? 6 squared will be 36. So, 64 plus 36 is equal to 100. And don't forget this root. And root 100 is equal to 10. So, it's equal to 10. So, 8 squared, root 8 squared plus 6 squared is equal to 10. That's it. Is this clear? Okay, so let's move on to our next step. So finally, what we're getting overall is this x squared. Okay, let's say finally we get, what do we get? The value of x squared is equal to 9. Or I'm going to say that the value of x squared, okay, let me write it again. Okay. I'm gonna, just make sure to, I just want this to be clear, okay? Yeah. So what I'm saying is this x squared is equal to 9, right? Yeah. And this y squared is equal to 1. So how can I write it, how can I write this in another way? How will I write it? I can write it x squared is equal to plus minus 3 and y squared is equal to plus minus 1. Okay, so can I write it like this way? So it's just this thing, okay, like 9. Okay, so what is this 9? We can write this 9 as 3. Okay, right? Of course we can. What is it saying? X squared. X squared is actually, not to get confused, it's actually, this thing. So x squared is equal to 9 and y squared is equal to 1. So what is it saying? X squared is equal to plus or minus. So we don't know, like, either it's a negative or positive. So, and this y is equal to, well, of course, this, yeah. So in this case too, we don't know if it's positive or negative. So that's what I wrote. Okay. From here, if it's clear, then let's move on. So from 2x and 2x and y are of opposite sign, right? Right? From these 2x and y are, like they're of opposite sign. So what I will say that I'm going to say therefore, I'm just directly going to write this Therefore, this x is, this x will be, I can say that this x is equal to 3 and y is equal to -1, right? Or what can I write? So as they're of opposite signs, so in the next case, I can say that this x is equal to -3 and y is equal to +1, right? Is this clear? Like these two cases are only possible, right? So what I'll say, so like through this way, I'm getting my answer that the z is equal, square root of z is equal to plus minus 3. What's it going to be? Minus or plus? Of course it's going to be minus. So minus iota. Right? Is this clear? like each step should be clear to us, okay? Like all these things, I hope this was clear to you, right? Okay, if it's, then let's move on to our second method and let's solve this question, as it's really easy, but you know, okay, so as you know, I talked about the formula in the previous video, and now like I'll be using this formula. So this is going to be mainly going to be our second method. So what's similar in the first method and second method is that in both the methods we have talked about this modulus. That's it, but they're still different, because I think, well, we know we didn't use a formula here, but we're going to use a formula in the second method. So let's have a look at it. So what's the second method? Second method that we're doing here is, now I'm going to say, okay, so I've just made a lot of space here. So to find the square root of 8, okay, let's take a twist. Okay, a little bit of twist. What if I'm going to say that 8, like at the place of negative we have plus? Well, I'm going to tell you that doesn't even matter, okay? But in the last, if in the question was given 8 minus 6 iota, in the answer we will still get this thing, okay? So we have to check is the answer same or not. But I'm taking a little bit of, twist a little. I'm going to put positive here, okay? So to find the square root of, okay. How about writing it too? Okay. So to find the square root of what do we have to find? 8 plus 6 iota. Okay? But I'm going to tell you the answer of 8 minus 6 iota 2 in the last, okay? So to find the square root of 8 plus 6 iota, we will determine the magnitude and what's the last thing? If you like the square root topic is clear to us, then you can absolutely say this. What we will determine is its magnitude and we'll compare with a plus iota b, right? Okay, so this magnitude mainly means to, the modulus, and compare with the a plus iota b is comparing, the real imaginary parts, right? Yeah, so let's, continue. So, we will, to find the square root of 8 plus 6 iota, I'm just going to write solution, okay? Just forget about the question. Or maybe just, okay, so let it be, whatever it is. So, solution. Now let's talk about solution. So the mod of, as I'm talking about the modulus, magnitude, right? So the mod of 8 plus 6 iota, what is it gonna be? Okay, so it's gonna be 8. Okay. Actually, I was writing, I was actually writing x at, there. But I was saying 8, but I was writing x. Saying something else, writing something else, like this usually happens. Okay, this modulus of 8 plus 6 iota, what is it going to be? 8 squared plus 6 squared, right? And it's just like this way. So we're going to get 10. So root 8 squared plus 6 squared is equal to 10, right? So we find out the magnitude, right? One thing that we can see is this a is equal to 8 and b is equal to, what is it equal to? 6, right? And 6, and this thing is greater than 0. Okay, if you really remember that thing, the point which I discussed with you, that that the mod of modulus of complex number is greater than is greater than 0, right? I discussed this. And we can see it here too. So this is how we can see it, that it's greater than 0, right? Okay, so we have found out the magnitude. Now we're going to finally compare it with a plus iota b. So now using the formula, what do we have? Our formula. What do we have? I'm going to say a plus iota b, right? A plus iota b. So I'm going to write here 8 plus 6 iota is equal to, if you really remember that, I hope you haven't forgot it. So I'm going to write it like this way. So in bracket, in this big square root, okay. So mod of z. So what is it? 10, right? So I'm going to write 10 here. Plus, what was the formula? I'll try to remember it. Okay, so I don't want you to remind about the formula. So, okay, so 10 plus a, right? A we had, and a is, what is a? A is equal to 8. I've just read, I've just written it here, right? So a is equal to 8 by 2 plus iota root. Okay, what is it again? I'm going to write 10 as there was mod z, and z is equal to 8 plus 6 iota, right? And minus is going to be here, and again a is equal to 8 by 2, right? So what am I going to get? I'm going to get 18 by 2, right? Yeah, 18 by 2 plus iota. 10 minus 8 will give us 2. 2 by 2, right? So I can just cut this, and 2 and 2 into 9, 18, right? Yeah. So what I have is here 1, root 1, okay? Okay, is this clear? Okay, so this root was, here cut 2, and we cancelled it, and so finally I got this plus or minus, right? Remember one thing, plus or minus, okay? Oh, actually I forgot to put here plus or minus because we don't know if the value is going to be plus or minus, so plus or minus, right? Okay, so I'm going to get plus or minus, okay, this root, it's going to be root 9 plus iota, which is going to be plus minus 3 plus iota, right? Oh, what we can see is we've got the same answer, just the difference between this minus and plus. Okay, so what if I had put the value here, what's the difference? That here we can see negative. So what we only had to do is here to put the sign negative. That's it. Negative, 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 and negative, okay? That's what we have to do. And this is how we'll get 3 minus iota. But I changed it to, so that we can, just easily solve it. But just, changing the sign of the plus. If I'm going to put minus at its place, then I'm going to get the same answer, okay? So I hope this is clear to you. So by using the formula too and by this method too. So I hope both the methods are clear to you, and that's all for today. And in the next video, I don't know what we'll be discussing about. So let's say I'm not exactly sure what we'll be discussing about. So thanks for watching and have a great day.